In the silent darkness of the cosmos, when the night sky unfurls its vast expanse of quietude, it seems to weigh upon the human spirit with an almost tangible pressure. We gaze upwards at the Milky Way, that silvery luminescence cascading like a river, drawing us into its mesmerizing depths. This galactic stream is composed of innumerable stars in a colossal flow, enveloping us within the immensity of space, evoking an overwhelming sense of awe, mingled with a profound solitude. Through the lifelong endeavors of scientists, employing meticulous counting and estimation techniques, it is posited that our Milky Way galaxy may harbor between 300 million and 100 billion planets, with the potential to sustain life. This figure draws upon the most recent data from the Kepler Space Telescope and the James Webb Space Telescope, refining previous estimates with greater precision.
For instance, by 2026, subsequent analyses of the Kepler mission have indicated that approximately 300 billion stars in the Milky Way might possess planets within their habitable zones, while observations from the James Webb Space Telescope have further corroborated the atmospheric conditions of many such worlds, including tentative detections of biosignature gases like methane and dimethyl sulfide on candidates such as K2-18b. These 300 million to 100 billion planets sound like a cosmic pledge of life's abundance, yet in the embrace of the Milky Way's 300 billion stars, they unveil a harsh proportionality. By a straightforward arithmetic averaging, perhaps only 1 in every 1,000 stellar systems harbors a planet suitable for life. This probability of 1 in 1,000 renders the quest for companionship among the stars as precarious as a candle flame flickering in the wind.
Moreover, with humanity's current observational capabilities, even incorporating the latest discoveries from the James Webb Space Telescope, only around 60 potential candidate planets have been confirmed. This tally, recorded in the 2025 NASA Exoplanet Archive and updated through 2026 with additional confirmations, reaching over 6,000 exoplanets in total, represents merely the minuscule tip of a vast iceberg adrift in the inky ocean of the universe. What conditions, then, must a planet fulfill to be deemed a cradle of life's promise? This inquiry transcends mere curiosity. It shapes the destiny of human migration in the distant future. To seek answers, we must delve back into the chaotic origins of stellar systems. The most pivotal element is the planet's constituent materials. Observing our own solar system, we discern a clear order that is far from random. The 4 inner planets are forged from solid rock, whereas the outer 4 are immense spheres of gas and ice. This demarcation arises from the severe temperature gradients during the birth of their stellar parent. In the formative phase, a vast protoplanetary disk of gas and dust swirled violently around the nascent sun. The temperature in this disk plummeted sharply from the center outwards. Near the sun, extreme heat vaporized all but the highest melting point metals and rocks, which condensed into solids, forming the initial building blocks of planetary embryos. Conversely, volatile molecules such as water, ammonia, and methane remained gaseous, unable to partake in the early coalescence. Thus, the inner solar system gave rise solely to arid, rocky planets. In contrast, in the frigid outer reaches, temperatures were sufficiently low for these volatiles to freeze into ice, rendering the planetary building materials extraordinarily plentiful. There, planetary cores grew rapidly, amassing mass with ease. Once a core exceeded 10 times the Earth's mass, it crossed a critical threshold, exerting formidable gravitational pull to accrete vast quantities of hydrogen and helium from the surroundings. The outcome was the genesis of gas giant planets, worlds devoid of solid surfaces, transitioning instead from tenuous atmospheres to high-pressure, high-temperature liquid metallic cores. Such environments preclude the maintenance of liquid water or ecological cycles, rendering them inhospitable to life as we comprehend it. A solid rocky surface emerges as an indispensable foundation for life's aspirations. However, recent research underscores the vital role of a planet's magnetic field in shielding its atmosphere from stellar winds.
According to scientific updates from 2026, habitable planets also require stable geological activity to cycle carbon and other elements, thereby sustaining a greenhouse effect. Yet, rock alone proves insufficient. Even the most rudimentary life forms necessitate respiration. This imposes a second stringent criterion: a stable atmosphere. Consider our Earth, an exemplar of fortune and perseverance. The atmosphere we inhale today did not exist from the outset. The primordial Earth was a veritable inferno, with immense internal heat and a convulsing crust. In that tumultuous era, molten magma erupted through volcanoes, expelling copious water vapor, carbon dioxide, hydrogen sulfide, and ammonia. This volcanic outgassing forged a thick yet toxic initial atmosphere, devoid of oxygen and antagonistic to life's nascent buds. Yet the cosmos intervened with a harsh but essential barrage. Earth endured innumerable impacts from asteroids and comets, celestial visitors from afar, bearing ice and organic compounds. These intruders not only supplied water for future oceans, but also disseminated primordial organic molecules.
As the planet's surface cooled, water vapor condensed into seas, stabilizing the environment. Then the true miracle unfolded. The earliest photosynthetic bacteria emerged, infusing oxygen into the air over billions of years, yielding today's nitrogen, oxygen-rich atmosphere. Based on the latest observations from the James Webb Space Telescope, by 2026, scientists have detected analogous traces of oxygen and other potential biosignatures in the atmospheres of distant exoplanets, such as tentative hints on TRAPPIST-1e, suggesting that similar processes may transpire elsewhere. The narrative of life's exploration extends beyond atmospheres to the planet's position relative to its host star, the habitable zone. Yet, this entails more than mere distance measurements to ensure water neither freezes nor evaporates. We cannot overlook the characteristics of the host star itself. Take red dwarf stars, the most prevalent in the Milky Way, with extraordinarily long lifespans.
Numerous planets reside in the habitable zones of red dwarfs, but at a lethal cost. Such planets must orbit exceedingly close, at merely 1/10 the Earth-Sun distance. In this proximity, they are exposed to intense magnetic storms and high-energy radiation. Red dwarfs are notorious for their capricious nature, with frequent flares unleashing X-rays and charged particles that can strip away a nearby planet's atmosphere in an instant. Furthermore, the gravitational forces at such close quarters induce tidal locking, where one face perpetually confronts the star, while the other languishes in eternal darkness. This extreme temperature disparity disrupts stable climatic cycles. In opposition, stable stars of intermediate mass, like our Sun, offer secure havens, permitting planets to orbit at safer distances, evading tidal locking and the fury of magnetic storms. Moreover, research from 2026 emphasizes that a planet's rotation rate influences habitability.
Excessively slow rotation may engender extreme weather patterns. Even with a rocky surface, atmosphere, and stable host star, if a planet's size errs, it becomes a desolate realm. Size and mass dictate fate. Behold our neighbor Mars, a sorrowful sibling. With a diameter slightly over half that of Earth, and a mass merely 11% thereof, it is too diminutive, its gravity feeble, and its internal core heat dissipated swiftly. Billions of years ago, Mars likely boasted rivers and lakes, as evidenced by sedimentary rock traces. But as its metallic core cooled, the global magnetic field vanished. Absent this shield, solar winds eroded the atmosphere layer by layer, diminishing pressure and rendering liquid water untenable. Concurrently, geological activity and volcanism ceased, collapsing mechanisms for regenerating greenhouse gases. The red planet devolved into a cold, arid desert.
Earth miraculously possesses the just right dimensions, sufficiently large to retain a molten core, sustain a robust magnetic field, and facilitate plate tectonics, regulating climate over eons. The convergence of all these elements on a single planet constitutes a coincidence so rare as to inspire trepidation. According to the latest science, by 2026, the James Webb Space Telescope has confirmed additional Earth-sized rocky planets, such as LHS 475b and GJ251c, igniting further quests for potential life. When our perspective expands beyond planetary concerns to the cosmic scale, a more brutal yet magnificent truth emerges. The number of observable galaxies is diminishing at an alarming rate, not a figment of science fiction, but a tragedy wrought by spatial expansion. How many galaxies, then, populate the universe? 2 trillion, 20 trillion, or the inconceivable 520 quadrillion?
These variances reflect the evolution of human vision rather than astronomical conjecture. Galaxies are the majestic islands in the cosmic ocean, the fundamental building blocks of everything. In antiquity, humanity, like a frog at the well's bottom, perceived the Milky Way as the universe's entirety. The 1990 launch of the Hubble Space Telescope lifted the lid from that well. Hubble gathered light from the past, traversing time, revealing that the Milky Way encompasses at least 200 billion stars. Yet, the most agonizing query persisted: how many galaxies lie beyond the Milky Way? To resolve this, astronomers conducted a daring experiment. They directed Hubble towards the darkest, emptiest patch of sky in the constellation Fornax, an area 1/10 the size of the full moon. Over 113 days, Hubble stared unblinkingly, employing ultra-long exposures to capture the faintest photons. The result was the world-shaking Hubble Ultra Deep Field image. In what appeared void, over 10,000 resplendent galaxies materialized. From this, extrapolations estimated that within the observable universe, a sphere centered on Earth with a radius of 46.5 billion light-years, reside approximately 2 trillion galaxies. However, updates from 2026 indicate this figure may be higher, as the James Webb Space Telescope has unveiled more concealed galaxies, with maps revealing up to 800,000 in slivers of space spanning 13 billion years. But 2 trillion is not the final tally. Scientists acknowledge Hubble's limitations, unable to perceive galaxies too ancient, too dim, or obscured by cosmic dust. Thus, on Christmas Day 2021, the $10 billion Golden Eye, the James Webb Space Telescope, was dispatched to the Lagrange Point 2, 1.5 million kilometers from Earth. With its infrared prowess, Webb illuminates the darkest recesses, beholding primordial galaxies formed mere hundreds of millions of years post-Big Bang. Webb's data affirm that Hubble's 2 trillion is a minimum. The universe is more crowded than envisaged. By 2025, Webb's revelations showed the early universe as more structured than anticipated, already hosting fully formed spiral galaxies, compelling revisions to cosmic evolution models. Moreover, the staggering 520 quadrillion arises from distinguishing the observable universe from the entire universe. The observable universe encompasses space whence light could reach us in 13.8 billion years. Yet the actual universe extends far beyond and inflates. Per mathematical models and theoretical physics, what we see is but 1 in 251 of the whole. Multiplying the 2 trillion observable galaxies by this factor yields the immense number. Terrifyingly, most galaxies forever elude our grasp. Due to the universe's accelerating expansion, distant galaxies recede faster than light speed. Their light will never arrive at Earth. We inhabit a privileged epoch, where the night sky still brims with stars. Civilizations born trillions of years hence will behold only black void, forever ignorant of today's splendor. According to 2026 research, dark energy may be evolving, potentially altering expansion rates, and perhaps culminating in a cosmic collapse. When the earliest astronomers trained telescopes skyward, they sought merely to comprehend their abode, unaware of touching space-time's cruel limits. Only later did they realize knowledge of fragile life on rocky planets, comprehension of vanishing galaxies,
stems from humanity's extraordinary exertion beyond biological bounds.
We ought to express profound gratitude to those who honed every lens, coded the controls for divine eyes adrift in cold void, and to theoretical physicists who spent lifetimes computing numbers in darkness. They erected bridges of knowledge, enabling humanity to transcend infinite dread and gaze upon truth's beauty. We hope, in the fleeting instant of our existence in cosmic history, that humanity cherishes Earth's blue radiance and the stars' glow before all sinks into time's eternal oblivion. Some lights visit once and vanish, but the understanding they bequeath shall warm human souls amid the universe's lonely night. From the darkness of ignorance, 520 quadrillion galaxies emerge like oracles, shattering all illusions of human centrality. Yet to truly fathom this number's weight, we cannot linger on arid calculations. We must embark on a soul's journey through the universe's macroscopic structure.
There, gravity serves as the supreme architect, weaving the immense cosmic web. If one could shrink the observable universe to a crystal ball in the palm, galaxies would appear not as random dust motes in sunlight, but entangled in fibrous structures, akin to a colossal biological neural network. These luminous filaments are woven from dark matter, which comprises most of the universe's mass, an invisible adhesive drawing galaxies into resplendent superclusters, while leaving absolute solitude in the voids between. Within this grand web, our Milky Way, Andromeda, and dozens of satellite galaxies form but a modest village on the periphery. This village drifts within a vaster structure named Laniakea in Hawaiian, signifying immense heaven. Laniakea is a supercluster encompassing over 100,000 galaxies, spanning a diameter of 520 million light-years. Envision traversing this homeland at light's 300,000 kilometers per second.
It would demand over 500 million years. Within Laniakea, galaxies flow like rapids, all drawn towards an enigmatic locus dubbed the Great Attractor, an anomalous gravitational zone at the supercluster's heart, exerting irresistible allure, pulling the Milky Way and millions of galaxies at 600 kilometers per second. We are in perpetual freefall, a descent enduring billions of years, towards a gravitational abyss obscured by the Milky Way's dense dusk disk, defying clear sight. Yet Laniakea's grandeur, or the cosmic web, pales against the truly mind-overwhelming, the essence of light and time, the sole instruments for touching the past. When the James Webb Space Telescope unfurled its hexagonal gold-plated mirrors in the chill void, 1.5 million kilometers from Earth, it was no mere camera, but a veritable time machine. The light from the farthest galaxies embarked in the universe's infancy, post-Big Bang, when the first stars ignited thermonuclear flames.
Over 13 billion years, spatial expansion stretched the light's wavelengths from ultraviolet and visible to infrared. Thus, human eyes, sensitive only to visible light, could never behold these ancient galaxies. Webb's infrared vision is requisite, capturing faint thermal traces at the cosmos's edge. Webb operates at temperatures below 50 Kelvin, minus 223 degrees Celsius, to prevent equipment heat from interfering with weak signals. A 5-layer sun shield, the size of a tennis court, blocks the sun's blaze, consigning mirrors and sensors to perpetual shadow and cold. Thanks to this absolute stillness, we discover that early universe galaxies were not the chaotic jumbles anticipated, but astonishingly ordered spirals. These galaxies housed population 3 stars, the primordial cohort forged from hydrogen and helium alone, 100 times our sun's mass, brighter and hotter, with brief yet ferocious lives culminating in supernovae.
These explosions seeded the universe with heavy elements: gold, oxygen, carbon, iron, the raw materials for subsequent rocky planets and life. Every atom in our bodies, from calcium in bones to iron in blood, is the ash of those antediluvian dead stars. We are the universe awakening to observe itself, the culmination of billions of years of material recycling. By 2026, WET may have secured direct evidence of population 3 stars, upending early universe models. Yet this majestic panorama conceals astrophysics' quiet tragedy, the accelerating expansion driven by dark energy. Comprising nearly 70% of the universe's energy, dark energy is a mysterious anti-gravity propelling spatial dilation. This yields cruel consequences, a cosmic event horizon. Galaxies beyond the Hubble radius recede superluminally. This violates no Einsteinian relativity, for it is not objects moving through space, but space itself inflating. If inflation exceeds light speed, a galaxy's photons resemble runners on a reverse conveyor belt, forever failing to arrive. Light stretches infinitely into low-energy radio waves, ultimately vanishing from our skies. Per 2026 studies, dark energy may be waning, potentially slowing expansion, or even precipitating a future big crunch. We dwell in a golden age, a rare just right moment in cosmic history. Had humanity arisen too early, the universe would be too hot, radiation saturated, heavy elements scarce for life. Too late, trillions of years hence, expansion would thrust all galaxies beyond observation. Then our local group, the Milky Way merged with Andromeda into the colossal elliptical Milkomeda, would stand as the sole grand entity. Milkomeda's inhabitants, gazing skyward, would see only their own galaxy's stars. Other galaxies, luminous gas clouds, the Big Bang's cosmic microwave background radiation, all erased. Their sky is black, silent, utterly alone.
Scientists of that era, no matter their ingenuity or colossal observatories, would logically err, concluding their galaxy encompasses the universe entire, space static, eternal, without beginning or end. They would forever remain ignorant of billions of galaxies, of Big Bang evidence, the universe's true history effaced by its own evolution. Today, we diminutive humans, graced by time's generosity, behold the past, unravel origins, appreciating the panorama before key fragments are rent and hurled into void. This positional awareness evokes deeper existential unease, infiltrating human dreams with ontological solitude, namely the Fermi paradox. Gigantic radio antennae point starward, hearkening to cosmic whispers, yet only heavy silence echoes. With trillions of galaxies, each harboring trillions of stars, countless rocky planets circling habitable zones, the odds of Earth as life's sole intelligent cradle are infinitesimal. But where are they? Why such spatial quietude? Perhaps distances form insurmountable prison walls. The universe's swiftest messenger, light, requires millions of years from galaxy to galaxy. A civilization might broadcast greetings, but upon arrival, that society has perished millennia prior, leaving only derelict planetary ruins. Or more painfully, intelligent life bears seeds of self-destruction. Civilizations attaining technological zenith, harnessing atomic power or artificial intelligence, simultaneously weave their own noose. Cosmic silence may be the graveyard of innumerable civilizations, failing maturity's and wisdom's test. Recent theories, such as the cognitive horizon hypothesis, propose civilizations stagnate in development, unable to surmount certain technological barriers. The mundane hypothesis suggests extraterrestrials lead low-profile existences, eschewing high-technology signals. By 2026, these theories have spurred enhanced life signal searches, like updated SETI Institute projects. The farther we peer, the smaller we seem, yet paradoxically greater. Before galaxies, our flesh is dust, but our minds encompass the cosmos through equations and speculation. From Chilean mountaintop observatories, where air is thin and dry, to control rooms awash in data screens, humanity assembles the cosmic puzzle. Each new light point, each spectral analysis, advances us towards the divine realm.
We no longer rely on mythic conjecture, but venture as explorers, armed with knowledge's light, confronting time's abyss, seeking our roots. When ancient astronomers linked stars into constellations, they sought solace, imposing order on primal nocturnal chaos, unaware those lights were burning worlds light years distant, gigantic nuclear furnaces capable of obliterating life in an instant.
Later, they awoke, possessing detailed maps of every galaxy, knowing our position in Laniakia's rapids, sensing the ultimate solitude of galaxies parting via eternal expansion. This is the fruit of generations' quiet sacrifice and collective wisdom. We ought to express profound gratitude to optical engineers who polished beryllium mirrors to atomic flatness, capturing feeble photons from the flood era, to programmers who toiled nights crafting intricate algorithms to excise atmospheric distortions, permitting human eyes to pierce cosmic fog, to astrophysicists confronting merciless numbers and austere equations to delineate reality, to vanguard knowledge frontiersmen guarding the flame before ignorance's darkness, dedicating their youth. Their devotion ensures we are not lost. In the overwhelming expanse of 520 quadrillion galaxies, humanity feels not insignificant, but motivated thereby to safeguard the blue planet's fragile life flame, letting our laughter, love, and speculation reverberate before eternal night descends, as proud testimony to existence. Some knowledge brings deep sorrow of finitude and decay, but that noble sorrow renders this moment beautiful, this breath, this heartbeat, more radiant, sacred, and precious. When the naked eye beholds the night sky, it resembles black velvet embroidered with eternal diamonds. Yet this is nature's astonishing optical illusion. Through time machines like Hubble or James Webb, the fabric rends, revealing an ocean of billions of galaxies in creation's and destruction's dance. Each light point not a single star, but a cosmic isle containing trillions of suns, each potentially warming unnamed planets.
But behind this suffocating beauty, modern astrophysics discloses a cruel truth. We live in a rare, just right instant. Miss it, and humanity falls into cognitive blindness. Imagine time as an ever-flowing river. Upstream, post-Big Bang, the universe too hot, dense, chaotic, radiation pervasive, atoms unformed, stars unlit. Human consciousness arising then would incinerate in primal flames. Downstream, trillions of years hence, the cosmic river turns desolate, cold void. Dark energy, the mysterious thrust rending space, overpowers gravity, propelling galaxies superluminally, vanishing beyond our event horizon. This is the future tragedy we must now envision. From afar, our local group, Milkomeda, the merged Milky Way and Andromeda, becomes the sole giant entity. Milkomeda's denizens, gazing upwards, see only their galaxy stars. Other galaxies, glowing gas clouds, Big Bang's cosmic microwave background, all gone. Their skies black, silent, utterly alone.
Scientists then would logically misjudge their galaxy, the universe whole, space static, eternal, without origin or terminus, forever ignorant of billions of galaxies, of Big Bang proof, cosmic true history erased by evolution. We present diminutive humans, favored by time's largesse, see the past, decode origins, savoring the vista before fragments are torn and cast into void. This awareness stirs deeper existential disquiet, seeping into human dreams with ontological loneliness, namely the Fermi paradox. Giant antennae aim starward, listening to cosmic murmurs, yet only ponderous silence resounds. With trillions of galaxies, each with trillions of stars, myriad rocky planets orbiting habitable zones, Earth's probability as life's unique intelligent cradle is minuscule. But where are they? Why such spatial hush? Perhaps distance is the Gale wall. Light from galaxy to galaxy demands millions of years. Civilization signals arrive when the civilization has extincted, ruins alone remaining. Or
Civilizations at pinnacle self-destruct. Silence, the cemetery of failed civilizations. New theories like sustainable solutions, where extraterrestrials go off-grid, emitting no high-tech signals, or development plateau hypotheses, where civilizations halt at specific stages. Amid dark nocturnal seas and eerie silence, Earth gleams as a more precious, fragile gem. Its thin, cyan-green atmosphere not only shields the planet from lethal radiation, but serves as the sole barrier from vacuum's absolute cold. On this islet, matter awakens. Billions of years ago, atoms of carbon, hydrogen, oxygen, nitrogen, forged in dead stars' nuclei, miraculously rearranged into beings that ponder, love, and query why. We are the universe's mode of self-knowing, its eyes, ears, conscience. The farther we gaze, the more introspective we become.
Human greatness lies not in physical scale. Dust before mountains, microbes before planets, not before galaxies. Greatness is the mind's capacity to encompass the cosmos. As Einstein's equations describe space-time curvature, quantum models predict subatomic behavior, humanity erects fortresses of knowledge with mathematical logic. Envision observatories atop highest Chilean or Hawaiian peaks, air rarefied and desiccating, skin chapping. Night falls, massive domes creak open like sacred eyes heavenward. In warm control rooms amid screen glow, people labor while the world slumbers, seeking not gold or power, but light, hunting feeble photons wandering the cosmos 13 billion years, impacting mirrors into tiny electrical signals, therewith mapping the universe, gauging expansion velocity, tracing dark matter's spore. Each discovery pushes ignorance's boundary. We no longer fear thunder or eclipses as divine wrath, torchbearers of reason, delving deepest secret caverns.
We know we arise from stardust, blood iron from supernovae, fate entwined with cosmos. This knowledge breeds not arrogance, but profound humility. Before space-time's vastness, petty quarrels, borders, racial animosities seem risible. From cosmic vantage, Earth a pale dot, no room for division. When ancient astronomers constellated stars into myths, they sought comfort, ordering primal nocturnal chaos. Unaware, lights were worlds ablaze, light years away. Giant nuclear reactors, capable of life-crushing in moments. Later awakening, holding detailed galactic charts, knowing Laniakia's Rapid's position, sensing far future galactic separation via eternal expansion's ultimate loneliness. This generation's sacrifice and collective wisdom's yield. Not miracle, but persistent sweat and tears.
We express gratitude to optical engineers polishing beryllium mirrors atomically flat to snare deluge-era feeble photons, to programmers night-long crafting complex algorithms removing atmospheric perturbation, letting eyes traverse cosmic mist, to astrophysicists facing relentless numbers and frigid equations portraying reality, to knowledge vanguard pioneers guarding flame before ignorance's dark, yielding youth. Their dedication ensures we are not adrift. In 520 quadrillion galaxies expanse, humanity senses not meaninglessness, but impetus to guard blue planet's life flame, letting laughter, love, thought echo before eternal night, as existence's proud witness. Some knowledge bears finitudes and decays deep sorrow, but that sorrow ennobles this moment's beauty, this breath, this heartbeat, more luminous, hallowed, precious.
Finally, in this odyssey of all knowledge, we express profound gratitude to the myriad scientists, researchers, research consortia, and their contributions. Gratitude to the Hubble Space Telescope team for their dedicated efforts in redefining the number of galaxies in the observable universe. Homage to the James Webb Space Telescope scientists and engineers for their steadfast work in unveiling early universe secrets and exoplanet enigmas. Deep respect to NASA exoplanet explorers, the Kepler mission team, and Search for Extraterrestrial Intelligence Institute researchers for their indomitable exploratory spirit in updating estimates of life potential planets. Moreover, sincere thanks to theoretical physicists laboring to reveal dark energy and cosmic expansion variations, astronomers proposing Fermi paradox interpretations, consortia mapping Laniakea and the great attractor structures, scientists exploring the cosmic web and void essences.
Their enduring efforts and pursuit of knowledge for society expand human understanding, fortifying us before cosmic mysteries. Their contributions shall shine eternally.